Welcome to Spaceverse, your portal to cosmic adventures. Imagine a future where we talk about astronomy as before Webb and after Webb. Sounds dramatic, right? But it might just be true. Something big is unfolding before our eyes. The real question is, are we witnessing an observational error, a misinterpretation, or is the universe throwing us a curveball? Could this be a hint of an unknown type of dark matter, a new form of dark energy, or something entirely unexpected? If there's a Nobel Prize in the making, this discovery might just be it. Now, take a look at this breathtaking image. What you're seeing is an incredibly distant cosmic structure shining brightly in the early universe. This discovery helps resolve a long-standing mystery in astronomy. Based on everything we know, the universe came into existence around 14 billion years ago. Following the Big Bang, there was a period of complete darkness known as the Dark Ages, when the universe was filled with thick clouds of gas. Even the most advanced telescope would have struggled to see through this cosmic fog. Yet for decades, astronomers have been puzzled by strange light appearing from within these dark clouds. Now, thanks to the Webb telescope, we finally have answers. For the first time, Webb has detected two ancient galaxies that don't quite resemble anything we've seen before. Their existence is challenging our understanding of how galaxies formed in the early universe. Could this discovery rewrite our cosmic history? One thing's for sure, astronomy will never be the same again. The Webb telescope is shaking up our understanding of the universe with some game-changing discoveries. Could we be wrong about the age of the universe? Or have we misunderstood how these ancient galaxies formed? For years, astronomers have been puzzled by mysterious lights coming from the depths of the early universe. Now, thanks to Webb, the mystery is starting to unravel. This latest image reveals that the light is actually a strong source of Lyman alpha emissions, something that tells us a lot about what was happening in those ancient cosmic times. What's even more surprising is that Webb's data shows there were far more galactic mergers in the early universe than we previously thought. These chaotic collisions triggered intense star formation, which in turn produced the Lyman alpha emissions. But here's the catch: scientists originally believed that these emissions should have been blocked by thick hydrogen clouds filling space during the Dark Ages. Yet we're seeing them anyway. So what's going on? Researchers now believe that as stars formed in these young galaxies, they did two things. They emitted Lyman alpha light, and they also carved out ionized hydrogen bubbles and channels in the surrounding gas. These gaps allowed the light to pass through, essentially letting us peer beyond the Dark Ages for the first time. And the surprises don't stop there. A recent deep field Webb image revealed two galaxies that existed even earlier than expected, beyond the darkness of the early universe. But these galaxies don't look anything like the ones we know. Could this mean we need to rethink how the first galaxies formed? One thing's for sure, the universe is far more complex than we ever imagined. These two galaxies are highly redshifted, and if they truly are galaxies, astronomers believe this could pose a significant challenge to our current understanding of the universe. Take a look at this graph. It provides a detailed overview of the farthest galaxies ever detected, made possible by the incredible capabilities of the Webb telescope. Among them is GNZ11, a galaxy first spotted by Hubble, located approximately 13.2 billion light-years away. But Webb has now revealed something astonishing. At the heart of GNZ11 lies a supermassive black hole, the most distant one ever discovered. What makes this discovery even more shocking is that this black hole formed just 400 million years after the Big Bang. Given its immense size, this finding challenges everything we know about how black holes form. According to current theories, the deaths of the first stars or early black hole mergers shouldn't have been able to create such a massive black hole in such a short time. This means scientists may need to completely rethink how these cosmic giants came into existence so early in the universe's history. But the surprises don't stop there. The latest Webb data has left astronomers stunned. As we analyze the most distant galaxies Webb has discovered, the red markers indicate those confirmed by spectroscopic observations. Right now, the most distant confirmed galaxy is called GZ130, which existed about 13.47 billion light-years away. However, there's something even more intriguing. The data also reveals two galaxies located at a redshift of around 16, meaning they existed beyond the Dark Ages, pushing the boundaries of our understanding of the early universe. It weren't supposed to form until the end of the Dark Ages. Yet here we are looking at massive and unusual galaxies that existed even before that period. This suggests something groundbreaking. Galaxies may have formed much earlier than our theories predicted. But that raises a big question. How is this possible? One possibility is that the universe is older than we currently believe. Another is that something unexpected happened after the Big Bang, perhaps an unknown process that rapidly accelerated the formation of the first galaxies. For now, spectroscopic observations of these galaxies have yet to be conducted. But if future observations confirm their predicted redshifts, it would shake the very foundation of modern cosmology. Interestingly, there's another idea gaining traction among scientists: conformal cyclic cosmology. This theory, proposed by Nobel laureate Dr. Roger Penrose, suggests that our universe didn't just begin with the Big Bang, but is part of an ongoing cycle of cosmic rebirths. According to Penrose, a universe existed before ours, what he calls the previous eon. In its final stages, black holes from that universe would have slowly evaporated, as predicted by Stephen Hawking. The energy released from this process could have then triggered the Big Bang of our current universe. The discoveries made by the James Webb Space Telescope have profoundly challenged our understanding of the universe, particularly regarding its age, structure, and origins. One fascinating hypothesis, proposed by Nobel laureate Dr. Roger Penrose, suggests that remnants of black holes from a previous universe could have influenced the expansion of our early universe. According to this theory, these so-called dead black holes may have played a crucial role in shaping the formation of supermassive black holes and massive galaxies much earlier than conventional models predict. If true, this idea could fundamentally reshape our perception of the universe's history and evolution. In just 3 years of operation, the JWST has already shattered numerous cosmic records, unveiling objects that existed at the very dawn of the universe. Among its groundbreaking discoveries are the most distant galaxy, the most distant protocluster of galaxies, the most distant black hole, the most distant red supergiant star, the most distant gravitational lens, and the most distant quasar. Each of these findings presents new puzzles that challenge the standard cosmological model. The unexpected presence of massive galaxies and fully formed black holes so early in cosmic history raises serious questions about whether our current understanding of the universe is incomplete. One of the most intriguing possibilities emerging from these discoveries is that the universe might be far older than previously believed. Alternatively, some scientists suggest that the universe could be part of a vast chain of interconnected universes, where each cycle gives rise to a new cosmic era. Another perspective posits that the universe has always existed without a definite beginning, meaning that the Big Bang was not the true origin but merely a transition in an ongoing cycle of cosmic evolution. Given the universe's apparent infinite size, the idea that it could also have an infinite age becomes a compelling possibility. Ultimately, these discoveries challenge us to rethink fundamental questions about the nature of existence itself. Are we witnessing the remnants of a past universe, evidence of a multiverse, or signs that time itself is not as linear as we once thought? As the JWST continues to peer deeper into the cosmos, it is likely that even more astonishing revelations await. Perhaps the greatest mystery is not just how the universe began, but whether it ever truly had a beginning at all. What do you think? Could our understanding of the cosmos be completely flawed? The answers may lie in the distant light captured by the JWST, waiting to rewrite the very foundations of cosmology. And that's it. Thanks for watching Spaceverse. JWST is reshaping our understanding of the universe. Could it be older than we thought? Drop your thoughts in the comments, like and subscribe for more cosmic mysteries. See you next time.